This is A2 Pure Mathematics. This is a past paper CCEA question, so we're in C4 January 2010 and it's integration. A trophy is to be made in the shape of a rugby ball. It can be modelled by the volume generated when the area between the curve y equals sine x and the x-axis between 0 and pi, so there's 0, there's pi, is rotated through 2 pi radians about the x-axis as shown in figure 2 below. Find the exact volume of the trophy. So exact means we need to keep our answer in terms of pi or e or whatever it comes out. We're not going to be using our calculator to get an answer to decimal places. So we want to take a wee look then at our formula. So our formula for this, for it rotating about the axis, is volume is going to be pi between pi and 0. Of pi sine squared x dx, because remember it's pi upon the r squared, so there's my r squared, and so I'm squaring my sine x in to get that. This here we need to think about how we're going to integrate it, so we're going to use the double angle formula to try and work it out. So over to the side, I know that sine squared x is equal to a half upon 1 minus cos 2x. Not to go on too much about this, but integrating powers of sine and cos and tan is really tricky, so we need to try and get rid of it and write it in as a double angle or something like that. So now my volume is then going to be, I'm going to take, so I'm changing this here for this here, and you see there's a half in there, so I'm going to take the half and the pi out the front, so that's going to be pi over 2. You can just about see this, we'll move it up, between pi and 0 of 1 minus cos 2x dx. We're now at a stage where we can integrate, so my volume then is going to be pi over 2, integrate the 1 with respect to x, I get an x, take away then, if I integrate cos I get sine, if I integrate cos 2x I get a half sine 2x. If you're not sure about that, you need to look at some of my notes videos, and that then is between pi and 0. I'm going to do a pi over 2 for these big brackets. I sub in pi in here, I'm going to get pi, take away a half, sine of 2 pi, I hope you realise that 2 pi is 360 degrees if you're converting to degrees, and the sine graph just comes back down again. We actually have a big bit of the sine graph up here, so we kind of go like that and then round to there, so it's actually 0, so that bit then goes to 0 for us. If I substitute in 0, 0 and 0, so that gives us nothing. So the only thing really coming out of this wee bit then is the pi. If we times the pi by that, I get pi squared over 2.